This is Miss Humbert here, and we are going to go ahead and take a look at Unit 5, Notes 1, so talking about ratios and proportions. So our very first notes of Unit 5. So let's just kind of take a look and let's define ratio and proportion a little bit. So what is a ratio? Well, a ratio is a comparison of two quantities using division. So a comparison of two quantities using division. So I'm going to figure out a way to write the ratio 2, 3. So here are the different ways that you can do that. We could write it as 2 over 3. We could write it as 2 to 3, being like that with 2 dots. Or we could actually write out the words 2 to 3. So those are the different ways that we can write out ratios. Now let's take a look at a couple of good examples of how we can apply ratios. So first and foremost, a baseball player's batting average is the ratio of the number of base hits to the number of at-bats, not including the walks. Joe Mauer had the highest batting average in 2006 in Major League Baseball. If he had 521 official at-bats over 81 hits, find his batting average. So to find his batting average, what we want to do is on the bottom, we want our total of at-bats. On the top, we're going to want our number of base hits. Okay, so we have base hits over at-bats. So how many base hits did he have? He had 181 base hits divided by how many at-bats he had, which is 521. So now in our calculator, we can do 181 divided by 521 to get his approximate batting average. And when you do that, you get about 0.347. Again, that's what you get when you divide those two numbers. Next, let's take a look at number 2. The number of students that participate in sports programs at Central High School is 520. Find the total number of students at the school is 1,850. Find the athlete to student ratio. Okay, so what we want to have here is we want to have our athletes on top, and we want to have our total students on the bottom. Well, our number of athletes is 520, so we have 520, and we want to put that over our total, which is 1,850. So again, to get the ratio, we're going to divide it. And when you divide it, you get about 0.281. So basically what that's telling us is about 28% of the population at the school is an athlete. Next, sometimes ratios compare more than two numbers. This is an extended ratio. So sometimes we can go ahead and we can create a whole bunch of ratios. So I do want you guys to write this down. So A to B, that compares the first two quantities. B to C, that compares the second two quantities. A to C, that compares the first and last quantities. So sometimes you will see this written out as A to B to C. So you can write it as one long strand as well if you want. Okay, but that basically means that we can compare A to B. We can compare B to C. And we can compare A to C. If all of those are lined up in the same ratio, we can compare all of them. So let's take a look at an example where we would do that. So the ratio of the measures of the angles in the triangle is 3, 4, and 5. So the angles. Okay, so what I'm going to do to figure out is I know that this one is 3 times a certain value, this angle is 4 times a certain value, and this angle is 5 times a certain value. So that's how we apply those ratios. We look at them as multipliers. So they're multipliers to each of those angles for x. So now we know that the sum of the interior angles of a triangle has to be 180 degrees. So we're going to go ahead and add all of those up. Okay, so 3 plus 4 is 7, plus 5 is going to give me 12. So I have 12x is equal to 180. So now I need to solve for x. So to do that, I'm going to divide both sides by 12. 180 divided by 12 is going to give me 15. So x is equal to 15. So now I need to get each of those angle measures. Well, to get the first angle measure, I'm going to take 3 times the 15. And when I do that, I get 45. Taking a look at the second angle, I'm going to get 4 times the 15. And when I do that, I'm going to get 60. Taking a look at angle 3, we're going to take 8 times the 15, and that is going to give us 75. Okay? Or I'm sorry, 5 times the 15. I'm not sure where I got 8 from. It's 5 because that was our last multiplier. Okay, let's take a look at this next one. The next one tells us in a triangle, the ratio of the measure of the sides, so now we're talking about the sides, is 3, 3, 8. So we have a multiplier of 3, a multiplier of 3, and a multiplier of 8. Okay, and all of those need to add to the perimeter, which is 392. So we're going to take and we're going to add each of those so that they add up to the perimeter. So 3x plus 3x plus 8x is equal to 392. So now I want to combine my like terms. 3 plus 3 plus 8 gives me 14 and then x, and that's equal to 392. So now I want to solve for x. So since that 14 is being multiplied, I'm going to divide both sides by 14. 392 divided by 14 is 28. So my x is equal to 28. To figure out each of my side lengths, now I have to apply it to each of the sides. So for the first side, I'm going to have 3 times 28, and that's going to give me 84. For side number 2, again, my multiplier is 3, so I'm going to have 3 times 28, so that's 84. And my last multiplier is I actually have 8, so I'm going to take 8 times 28, and that's going to give me 112. So if you were to add all of those up, you should get a perimeter of 392. All right, let's take a look at this next one. Jane jogs the same path every day in winter to stay in shape for the track season. She runs at a constant rate and spends a total of 39 minutes jogging. If the ratio of the times of the 4 leg is 3 to 5 to 1 to 4, how long does the second leg of the jog take her? So we're going to let x represent her pacing. So x represents how fast she's going. Okay, so for the first leg, it's going to be x times a multiplier of 3. For the second leg, it's 5. Or it's our pacing times the multiple of 5. For our second one, it's just the x, because it's just, you could write 1x if you wanted to. And then the second, or the last, is a multiple of 4. Now, all of that needs to add up to be 39 total minutes spent jogging. So now we're going to go ahead and calculate this out for x. So 3 plus 5 plus 1 plus 4, well, that's going to give us 13. So I get 13x is equal to 39. So now I'm going to solve this for x. So I'm going to divide both sides by 13, and I get that x is equal to 3. So that represents our pacing. But we want to take a look at the second leg. Well, the second leg has that multiplier of 5. So to get the pacing of the second leg, I need to take 5 times my x, which is 3. So I get that that second leg is going to take me 15 minutes of the total 39 minutes. Okay, so that's going to take 15 minutes. All right, let's take a look at some of these proportion stuff. Okay, so for a proportion are two ratios that are equal to each other. Okay, proportions are two ratios that are equal to each other. So how do we solve that? Well, we solve it by cross multiplying and dividing. So cross multiplication is something that was introduced to you in algebra. So let's go ahead and let's review that a little bit. So for number 6, we need to cross multiply. So what that means is I'm going to multiply across my fractions. When you have two fractions that are set equal to each other, you can use cross multiplication. So I'm going to take 5 times 2 and set it equal to 8 times x. Well, 8 times x is just going to give me 8x, and 5 times 2 is going to give me 60. So now I need to solve this for x. So this 8's being multiplied by the x, so I'm going to divide both sides by 8. 60 divided by 8 is going to give me 7.5. So 7.5 is the answer for number 6. Let's take a look at number 7. So for number 7, again, we're going to cross multiply. We're going to take 2 times x minus 2 and 4 times x plus 4. So we have 2 times x minus 2. Notice that I put it in parentheses because I'm going to have to distribute that 2. 4 times x plus 4. Again, so I'm going to distribute this 2, and I'm going to distribute that 4. Okay, so 2 times x is 2x. 2 times a negative 4 is a negative 4. 4 times x is 4x. 4 times 4 then is going to be 16. So now we need to get our x's on the same side. I'm going to bring this over to the other side. So I'm going to subtract 2x from both sides. So then I get that negative 4 is equal to 2x plus 16. So now I need to continue solving that for x. So what I'm going to do next is I am going to just move this down here quickly. Give us a little more space. Okay, so now to get that 16 over to the other side, I am going to subtract 16. So then I end up getting a negative 20 is equal to 2x. Divide both sides by 2, and you end up getting x is equal to negative 10. So x is equal to negative 10 is your final answer for number 7. Next, let's take a look at this one. So this one is going to involve factoring, which is something you learn and something we're going to be reviewing a little bit in this unit. So you're going to multiply that times that and that times that. So we end up getting 2x plus 3 times x minus 1 is equal to 6 times 3, which is 18. Now, in order to multiply two things like that, you learn something in algebra called the box method. Okay, so we line up our terms up here, and we line up our terms on there. If you forgot how to do this, let me know, because I have some videos from my algebra class that I can send you to that'll help out more. So now we're just going to multiply into the box. 2x times x is 2x squared. 3 times x is 3x. Negative 1 times 2 is negative 2x. And negative 1 times 3 is negative 3. So now I'm going to write out all of that. So I have 2x squared to start off with. Then 3x minus 2x is just going to give me x. And then negative 3 is equal to 18. So now in order to solve this, we have to get that 18 over to the other side. So I'm going to go ahead and subtract 18 from both sides. So I get 2x squared plus x minus 21 is equal to 0. So now I need to solve this by factoring. So I'm going to take 2 times a negative 21. Well, that's going to give me a negative 42. So I need to multiply to a negative 42 and add to 1. So that's going to be 6 and negative 7. So now I'm ready to set this up for factoring. So I have 2x squared plus 6x minus 7x minus 21. So what I did is I split up this middle term. Instead of writing 1x, I wrote it as 6x minus 2 is equal to 0. So now I'm going to factor by grouping. So between 2 and 6, I can divide out a 2 and an x. When I divide out 2x, I'm left with x plus 3. Between 7 and 21, now since there's a negative sign here, I'm taking out a negative GCF. Between 7 and 21, I can take out a 7. And I'm actually dividing each of those by a negative 7. So then I get my leftovers as x plus 3. So I can go ahead and I can factor these out. And once I've factored these out, I'm going to write what's left after that, which is 2x minus 7. Now this is going to be set equal to 0. So I'm going to finish this up on a second video since I have to stay below 15 minutes. So go ahead and click part 2 to finish up.